In this podcast episode, Lex Fridman interviews several key figures involved in Neuralink: Elon Musk, DJ CEO, Matthew McDougall, Bliss Chapman, and Nolan Arbaugh. Elon Musk begins by discussing his recent experience taking ayahuasca in the Amazon jungle. He describes it as an incredibly intense experience where he took an extremely high dose of 9 cups over 2 days. Musk says he had no demons or negative experiences, only positive ones. He felt deep gratitude for the people in his life and saw them glowing. He also experienced space travel, seeing Earth, the solar system, and galaxies, all of which were glowing with the same life force he saw in humans. He reflects that this made him feel there is life throughout the universe. The conversation then shifts to Neuralink and its recent milestone of implanting a device in a human for the first time. Musk explains that Neuralink's goal is to improve the AI-human symbiosis by increasing the bandwidth of communication between humans and computers. He notes that even in a benign AI scenario, AI would get bored waiting for humans to communicate at our slow rate. He sees Neuralink as a way to potentially mitigate existential risk from AI by allowing humans to keep up. Musk discusses the technical details of the Neuralink device, explaining it has 1,024 electrodes that can both record and stimulate neurons. The surgery to implant it took about 3.5 hours. He says they were able to see neural signals immediately after surgery as the patient was waking up. He emphasizes that while other brain-computer interfaces have been done before, Neuralink's approach of using many tiny flexible threads is novel and appears to cause minimal damage to brain tissue. Looking to the future, Musk says they hope to dramatically increase the number of electrodes and improve signal processing. The goal is to achieve much higher bandwidth, potentially reaching megabits per second in 5 years. This could enable entirely new ways of interacting with computers and other humans. He speculates this could improve intellectual discourse by allowing people to communicate complex ideas much faster. Musk also discusses Neuralink's plans for restoring vision in blind people by stimulating the visual cortex. He notes this could potentially allow people to see in different wavelengths beyond visible light. Other future capabilities could include helping with neurological issues like seizures or depression. The conversation touches on philosophical questions about consciousness and the nature of reality. Musk ponders whether our perception of reality is fundamentally limited by our biology, and if technologies like Neuralink could expand our understanding. He also reflects on the fragility of civilization and the importance of becoming a multi-planet species to improve humanity's long-term survival prospects. DJ CEO, co-founder and CEO of Neuralink, discusses his background and motivation for working on brain-computer interfaces. He describes being fascinated by the brain from an early age, influenced by experiences like seeing family members with Alzheimer's disease. DJ studied electrical engineering in college before pursuing a PhD focused on building tiny implantable devices to interface with the nervous system. He explains the core technology behind Neuralink's brain-computer interface, which consists of ultra-thin flexible electrode threads that can be inserted into the brain to record neural activity. DJ details the challenges of designing electrodes that can survive in the harsh environment of the brain while still effectively recording high-quality neural signals. He emphasizes Neuralink's vertically integrated approach, with the company developing custom technologies for everything from microfabrication to surgical robots. DJ walks through the full Neuralink system, from the implanted device to the external app that decodes neural signals into computer inputs. He explains how they use machine learning algorithms to map patterns of neural activity to intended movements or actions. He notes that a key challenge is developing robust decoding models that work consistently over time, as neural signals can drift or change. Discussing the recent milestone of implanting a device in a human for the first time, DJ describes the intense preparation process, including extensive practice surgeries on anatomically accurate models. He conveys the mix of excitement and nervousness leading up to the surgery, and the relief and joy when they saw the device successfully recording neural signals afterward. DJ reflects on the potential impact of Neuralink's technology, from restoring capabilities for people with paralysis to potentially augmenting human cognition. He speculates about future applications like restoring vision or interfacing directly with AI systems. He emphasizes that Neuralink aims to develop a generalized neural interface platform that could be applied to many different brain regions and functions. Looking ahead, DJ discusses plans to scale up the number of electrodes and expand to new brain areas beyond motor cortex. He notes the goal of making the technology safe and effective enough that even people without medical needs might choose to get an implant. He expresses optimism about the long-term potential to dramatically enhance human capabilities and interface with artificial intelligence. Matthew McDougall, head neurosurgeon at Neuralink, discusses his background and path to neurosurgery. He describes being fascinated by the brain from a young age, seeing it as containing all of humanity's problems and potential solutions. McDougall initially studied neuroscience before deciding to pursue neurosurgery to have a more direct impact on patients' lives. He reflects on the challenges of neurosurgery training, including the intense workload and competitive culture. McDougall notes that neurosurgeons often develop an air of authority that can be counterproductive, and he tries to maintain humility. He credits his ability to work well at Neuralink partly to this humility, as Elon Musk does not defer to appeals to authority. McDougall describes the surgical procedure for implanting the Neuralink device, emphasizing how relatively simple and low risk it is compared to many other brain surgeries. He explains how they use brain imaging to precisely target the hand area of motor cortex, then create a small opening in the skull to insert the electrode threads. He notes that while the human surgeon's role is straightforward, the robotic system that inserts the threads with microscopic precision is critical. Discussing the first human implantation surgery, McDougall conveys the heightened pressure and scrutiny, but says the procedure itself went very smoothly. He expresses relief and excitement at the successful outcome. He reflects on the broader impact of the technology, seeing it as a powerful tool to reduce suffering and enhance human capabilities. Looking to the future, McDougall speculates that surgical robots may eventually be able to perform most or all of the procedure autonomously. He sees brain-computer interfaces as having enormous potential to treat neurological conditions and augment human cognition. He expresses a willingness to get a Neuralink implant himself once the technology is sufficiently advanced and proven safe. Bliss Chapman, brain interface software lead at Neuralink, discusses his motivation for working on brain-computer interfaces. He describes meeting hundreds of people with spinal cord injuries or ALS and being inspired to help restore their independence and capabilities. Chapman emphasizes that while there are many assistive technologies, brain-computer interfaces offer unique advantages in terms of always being available and not requiring physical movement. Chapman walks through the technical details of how Neuralink's system works, from recording neural signals to decoding them into computer inputs. He explains the challenges of developing robust decoding algorithms that can adapt to changing neural signals over time. He describes their approach of using machine learning to map patterns of brain activity to intended actions. Discussing the recent milestone of the first human implant, Chapman conveys the excitement and pressure of the moment. He describes seeing live brain signals coming from the implant for the first time, calling it a surreal and inspiring experience. He reflects on the rapid progress they've made since then in improving the system's performance and capabilities. Chapman goes into depth on the process of calibrating and training the brain-computer interface. He explains how they use tasks like a bubble-popping game to collect data on how different imagined movements correspond to neural activity. He notes the challenge of obtaining accurate, ground truth data on what the user is actually trying to do at each moment. He discusses their work on improving the user experience, developing intuitive ways for users to control the cursor and interact with computers. Chapman describes features like magnetic targets that make it easier to click on small buttons. He emphasizes their goal of making the system feel as natural and effortless to use as possible. Looking ahead, Chapman expresses excitement about scaling up the number of electrodes and expanding to new brain areas. He speculates about future capabilities like direct brain-to-brain communication or interfacing with AI systems. He conveys optimism about the long-term potential to dramatically enhance human cognitive capabilities. Nolan Arbaugh, the first human to receive a Neuralink implant, discusses his experience with the technology. He begins by describing the diving accident in 2016 that left him paralyzed from the shoulders down. Arbaugh reflects on how he maintained a positive outlook despite the challenges, crediting his faith and support from family and friends. Arbaugh recounts the process of being selected for the Neuralink trial and his decision to participate. He says he was excited by the opportunity to be a pioneer and potentially help others and wasn't afraid of the surgery. He describes waking up after the procedure and immediately being able to see his brain activity on a screen, which he found fascinating. He walks through his experience learning to use the brain-computer interface, starting with simple tasks like moving a cursor on a screen. Arbaugh explains how he initially had to actively attempt to move his paralyzed hand to control the cursor, but eventually learned to do it just by thinking about the movement. He describes this transition as a profound moment that made him realize the full potential of the technology. Arbaugh discusses playing games like WebGrid to test and improve his control. He details his progress in increasing his speed and accuracy, eventually breaking world records for brain-computer interface performance. He conveys his competitive drive to keep improving and setting new records. Arbaugh reflects on how the Neuralink system has improved his independence and quality of life. He describes being able to use computers and play games on his own for the first time since his injury. He expresses gratitude for the freedom and autonomy this has given him. Looking to the future, Arbaugh discusses his hopes for upgraded versions of the implant with more electrodes and capabilities. He expresses interest in features like being able to control robotic limbs or regain sensation. He conveys optimism about the potential for the technology to help many others with paralysis or other neurological conditions. Throughout the conversation, Arbaugh demonstrates a positive attitude and sense of humor about his situation. He expresses deep appreciation for the Neuralink team and their dedication to developing the technology. He sees his participation in the trial as a way to contribute to scientific progress and help others facing similar challenges.